Want a smarter AI model? Make it bigger. More parameters means more knowledge, better reasoning, better results. That's been the formula for 5 years. LLaMA 2 has 70 billion parameters, and it uses every single one of them for every token it processes. Every word, every comma, every period. The full model fires. It works, but here's the cost. If you want a model twice as smart, you need roughly twice the parameters, which means roughly twice the compute for every single token. So you're stuck. Smarter means bigger, and bigger means slower and more expensive to run. For a while, it seemed like you had to choose one, capability or efficiency. Then researchers found a way around it. What if your model could have hundreds of billions of parameters, but only activate a small fraction of them for each token? The important parameters fire. The rest stay idle. That's the core idea behind Mixture of Experts, and it's quietly become the architecture behind almost every frontier AI model today. Here's how a standard transformer works. A token comes in, passes through an attention layer that figures out how it relates to other tokens, then through a feed-forward network. That feed-forward layer is where most of the model's parameters live, sometimes over 60% of the total. And every single token passes through the exact same feed-forward layer every time. No shortcuts, no skipping. Mixture of Experts replaces that one big feed-forward layer with multiple smaller ones. Each one is called an expert, and sitting in front of them is a small network called the router. When a token arrives, the router looks at its representation and picks one or two experts to handle it. The rest don't activate at all. The selected experts process the token independently. Their outputs get weighted by the router's confidence scores and combined. The attention layer stays exactly the same. The only thing that changes is the feed-forward step. Think of it like a hospital. A dense model is one doctor who examines every patient for every possible condition. Thorough, but slow and expensive. A Mixture of Experts model is a hospital full of specialists. A patient walks in, the triage nurse checks their symptoms and sends them to one or two departments. The cardiologist and the neurologist might handle this case, while the dermatologist and the orthopedist sit idle. The hospital has the combined knowledge of every specialist, but each patient only sees the relevant ones. Here's what that looks like in practice. Mixtral 8x7b has 47 billion total parameters across 8 experts, but only 2 experts activate per token. That's about 13 billion parameters. You get the knowledge capacity of a 47 billion parameter model at the compute cost of a 13 billion one. The router is what makes the whole system work, and it's simpler than you'd expect. It's a single linear layer. The token's hidden state gets multiplied by a weight matrix, producing one score per expert. Softmax converts those scores into probabilities. The top 1 or 2 experts get selected based on who scores highest. Their outputs get weighted by those probabilities and summed together. One matrix multiplication decides where every token in the model goes, but there's a problem that shows up almost immediately. If one expert starts performing slightly better early in training, the router sends more tokens to it. More tokens means more training signal, which makes that expert even better, which sends even more tokens its way. Meanwhile, the other experts get fewer tokens, fall behind, and eventually stop learning anything useful. This is called expert collapse. In the worst case, every token ends up going to the same 2 experts. Your 8-expert model becomes a 2-expert model with 6 dead weights. You built a hospital with 8 departments, but everyone's lined up outside cardiology. The classic fix is a load balancing loss. During training, you add a small penalty that pushes the router to distribute tokens more evenly across experts. But it's a delicate balance. Too little and experts collapse. Too much, and you force the router to send coding tokens to a poetry expert just to keep the numbers even. Recent models have gotten creative here. DeepSeek V3 dropped the balancing penalty entirely and instead uses dynamic bias terms that adjust during training. No auxiliary loss needed. They also introduced shared experts. 1 or 2 experts that always process every single token, regardless of routing. These shared experts learn the common knowledge all tokens need, which frees the routed experts to specialize much more aggressively. Mixtral 8x7b was the moment Mixture of Experts went mainstream. Released in late 2023, it was the first open-source Mixture of Experts language model people could actually download and run. 47 billion total parameters, 13 billion active per token. It matched or beat LLaMA 270b on almost every benchmark, while running about 6 times faster at inference. A model with a fraction of the active compute, delivering the same quality as one that's 5 times larger. After Mixtral, Mixture of Experts took over. DeepSeek V3, 671 billion total parameters, 37 billion active. 256 individual experts, 8 active per token. Databricks released DBRX with 16 experts. xAI's Grok uses 8. Alibaba's Qwen models have scaled up to 128. And GPT-4 is widely believed to use Mixture of Experts under the hood, though OpenAI has never confirmed it. The trend is unmistakable. More experts, smaller each, and increasingly precise routing. But there's one trade-off you can't engineer away: memory. Even though only a handful of experts activate per token, every single one of them has to be loaded into memory, ready to go at any moment. DeepSeek V3 has 671 billion parameters sitting in memory so that 37 billion can run per token. You save on compute, but not on memory. That's why running these models locally is tricky. Mixtral 8x7b needs around 26 gigabytes just to load the weights. A dense model with the same active compute would need far less. This is the fundamental tension of Mixture of Experts. You're trading compute efficiency for memory cost. And as expert counts keep climbing, that tension only gets sharper. For years, making AI smarter meant spending more compute on every single input. Mixture of Experts broke that link. A model can store vast knowledge across hundreds of experts and only activate the ones each token actually needs. Instead of one massive brain working on everything, you get 256 smaller ones. And only the right ones wake up for each token. We went from 8 experts in Mixtral to 256 in DeepSeek V3 in just over a year. Routing has evolved from simple top-2 gating to fine-grained, loss-free balancing with shared experts. Hybrid architectures are combining Mixture of Experts with entirely new model designs. The question isn't whether the next generation of AI models will use Mixture of Experts. It's how many experts they'll have and how small each one can get.